Hello. So today we're going to be looking at oxidation numbers. We'll be looking at the rules that are required to determine oxidation number of different elements and of compounds. We'll also be looking at a few examples. So let's start by examining the rules. So there are, I would say, about 6 or 7 rules. So let's check it out. The first one, elements have oxidation number of 0. Example, sodium. We see here sodium has an oxidation number of 0, sodium by itself, or chlorine. If an element, something is an element if it's bonded to its own self or exists by itself. So in this case, we have sodium being an element, and also chlorine is also an element. So elements always have oxidation number of 0. The second rule is monoatomic ions have an oxidation number equal to the charge of the ions. Example, sodium chloride. Sodium chloride has a charge of, the sodium in sodium chloride has a charge of +1, so the oxidation number of sodium in the sodium chloride will also be +1. And chlorine has a charge of -1 in sodium chloride, and the oxidation number of the chlorine would be -1. So we can look at rule 3. Any element from group 1 or group 2 will always have a +1 and a +2 oxidation. If the element exists in a compound, let's say if the metal, let's say, sorry about that, not element, if the metal exists in a compound, if the metal exists in a compound and the metal is from group 1 or group 2, then that metal will have an oxidation number of +1 and +2 respectively. Here I gave you 2 examples. We have sodium chlorides. Of course, sodium is from group 1, so it's going to have an oxidation number of +1. Magnesium is from group 2, is going to have an oxidation number of +2. Rule number 4, chlorine is always -1. So if you have chlorine in a compound, that chlorine oxidation number will always be -1. Chlorine being, of course, the most electronegative element in the periodic table, so it's going to have a -1. Other halogens also can have -1, but when they are bonded to a more electronegative element, when they are the most electronegative element in the compounds. If they are not, then the oxidation number can vary. Hydrogen, rule number 5. Hydrogen in a compound will have a +1 unless it's bonded to a metal. Example, we have HCl here. HCl, this is a compound and it's not bonded to a metal because chlorine is a non-metal. So in this case, hydrogen will have a +1. But if we have lithium hydride, so we have hydrogen is in a compound, hydrogen is in a compound, however, it's bonded to a metal. So if that's the case, hydrogen is going to have an oxidation number of -1. Now we're down to rule number 6. Oxygen usually have a -2 if it's in a compound, except of course it's bonded to fluorine, the most electronegative element. So in that case, oxygen will have a +2. So here we have an example, magnesium oxide. So oxygen is in a compound here. So, and this magnesium is bonded to magnesium, not fluorine. So the oxygen is going to be -2. Whereas if it's bonded to fluorine, the oxygen is going to be a +2. Rule number 7. The sum of the oxidation number in all compounds is equal to 0. So let's look at our compound here, sodium chloride. Here we know sodium is a metal from group 1. It has a +1 oxidation state. Chlorine is a halogen and it's the most electronegative element here. It has -1, and +1 plus -1 is equal to 0. So the sum of the oxidation number in all the compounds is equal to 0. So the sum of these oxidation numbers must be equal to 0. This is relevant because sometimes we will know one oxidation number and we don't know the other. But if we know they add up to 0, we can use that to determine the unknown. Here's another example where we looked at magnesium chloride. Magnesium is found in group 2. It has an oxidation number of 2 plus 2. Chlorine has an oxidation number of -1. Since there are 2 chloride, it's -1 and -1. So if you add these up, again, you're going to get summation of 0. And the last rule, the sum of the oxidation numbers in polyatomic ions add up to the charge of the ions. So this is saying if we add the oxidation number of the of the nitrogen and the 3 oxygen, we must get this to be equal to -1. So let's look at this example. Nitrogen, from previous examples, not here, but a previous example, we know that nitrogen is +5, and oxygen is -2. So +5, and we have 3 oxygens, so we're going to end up with -6. +5 and -6, we get -1, and that's what we end up here. So these are the rules with which we have to use in order to determine oxidation number. So we're going to try some examples. Let's look at the first one. So what is the oxidation number of nitrogen? So if you have a formula like N2 and I ask you what is the oxidation of nitrogen here, so first thing you're going to say, is nitrogen an element or a compound? N2, this is an example of an element, and so we'll look at our rules and we'll see all the way to rule number 1. Elements have oxidation number of 0. Right, so using rule number 1, so rule 1 tells us nitrogen oxidation number is equal to 0. Okay, let's look at another example. Sodium sulfide. And we want to know the oxidation number of the sulfur. Okay, so we realize this is not an element, it's a compound. And we are seeing sodium. And we can tell sodium is from group 1. Right, so if we look at our rules, we would know that if an element is from group 1, so we could look at rule number 3. So rule number 3 tells us if an element is from group 1 or group 2, it has an oxidation number of +1. And we also know rule number 7, where we're saying that the sum of the oxidation number is equal to 0. So let's check it out. Rule 3, let's see if we're correct. Rule 3, metals in group 1 and 2 always have oxidation number of +1 and 2. And check rule number 7. The sum of the oxidation number in all compounds is equal to 0. So based on that, we're going to say, so sodium is in group 1, so it has an oxidation number of +1. We have 2 sodium, so it's +1, +1, and sulfur, we don't know sulfur, right? Let's call it X. And all of this must be added to 0. So it's +2 plus X is equal to 0. So from this, we can tell that X is equal to -2. So sulfur oxidation number is equal to -2. Okay, we'll try one more example. Let's look at CO3 2-. And what if we want to know the oxidation number of the carbon, right? So we're going to look at rule number 6 that tells us the oxidation number of oxygen is -2, right? Unless it's bonded to a more electronegative element here. It's not, so oxygen is -2. So we're going to use rule 6, and we're also going to use rule number 8. The sum of the oxidation number in a polyatomic ion is equal to the net charge. So rule number 8. So from this, so we're trying to find carbon. So we don't know carbon, we're going to call it X. It's only one carbon, so it's X plus each oxygen is -2. So -2. And since we have 3 oxygen, we could go ahead and put a 3 here. Instead of adding it 3 times, that's much more simpler. And these must add to -2 or 2-. It doesn't matter how you want to write it, -2 or 2-. So X minus 6 is equal to -2. So to find what X is, we're trying to get rid of the 6 portion. We're going to add 6 to the side. We're going to add 6 to the side. Whatever you do on one side of the equation, you must do on the other side. So in that case, this is going to cancel. So we're going to be left with X is equal to +4. So in this case, carbon has an oxidation number of +4. Okay, so you could try out examples on your own. Hope this helps.